Welcome. Today we're walking through a Ttest problem. Feel free to pause if you want to read it. But just to jump into the knowledge we need to even start this problem, first off, you need to know a two-sided test versus a one-sided test. So that's just saying in this problem, we specifically see it says brother and sister scores are not equal. It doesn't say that brother scores are larger than sister scores or brother scores are less than sister scores. It's that I don't know which one could be larger or not. My alternative hypothesis is just they're different. And that's how you know it's a two-sided test versus a one-sided test. Second thing is when to use a t-test. So one of the first things you learn is a z-test, where all you want to do is test for a difference in the sample average, or you're testing for the average. T-test is when you are not only having to estimate the sample average, but you also have to estimate your variance. So while you're trying to test for a difference in average, I want to test whether brother and sister scores are equal or not equal. Even though it's not part of my test, I need to account for and estimate the variance. And so what that does is that's going to increase the variance of my test statistic. That's just a separate moving parameter you have to account for. So when you're doing a t-test, you're going to need to know the degrees of freedom to be able to use the t-table, and that's just going to be the sample size minus 1. And then separately, you don't need to know this, but I think it's conceptually useful, is that a t-test, as the sample size approaches infinity, is going to approach a normal distribution. And that's just because, again, you're trying to account for that increased variance due to having to also estimate the sample, using the sample variance to plug that in as the variance you use for your overall t-distribution. But if your sample size is increasing, your estimate of the true variance is going to approach the true variance. And that's why you're going to approach a normal distribution as your sample size increases. So just thought I'd point that out there. And then the final thing I have here is a paired t-test. So really it's just saying when you care about differences instead of the multiple metrics. So I think other common versions of this are, drug trials. You'd say, I care about your weight before and after taking a weight loss pill or changing your diet, or any other kind of before and after where you want to compare things directly. And the way we know that applies to this problem is that we don't care about men's scores versus women's scores. We care about brothers versus sisters. So we're saying I care about the difference between this 89 and this 86, and this 94 and this 95. I don't care about the overall average of all brothers and the overall average of all sisters, and want to test whether those two things are different. So it's kind of subtle in the wording here, but what you're trying to get at, I'd say the wording here is somewhat ambiguous, but the fact that they're saying brothers and sisters and not just men and women is also pointing to the fact that you need to do a paired t-test, because you want to make that direct comparison. And that's really simple in terms of all you need to do is calculate that difference and look at the difference instead of the raw values, and then just do a traditional t-test with those differences. So that's what we're going to do. So first up, just calculate those differences. So 3, -1, 7, and 3. I'm doing the brother minus sister. You could also do it the other way around. Our sample average is going to be 3. I have written out here how to calculate and that should say sigma hat squared, how to calculate the variance estimate by hand, but I would recommend getting familiar and quick at calculating variances with your calculator. I think it's a good time saver. So I have a separate video, maybe I'll link to that, walks through how to calculate the sample average and sample variance. but definitely a skill worth learning to save you some time during the exam. But we end up getting that the variance is, or estimated variance is 32 over 3. Finally, we got to calculate our test statistic, so that's just going to be your value minus the true value or assumed true value divided by the standard deviation. And for that, we're saying what's our sample average minus our null hypothesis, which is just that there is no difference between brothers and sisters, so 3 minus 0, and then divided by our standard deviation estimate divided by the square root of n. And that's because we're not interested in the variance of the difference between brothers and sisters. We care, since we're using the x bar, we're trying to use the estimate for the variance of a sample average of size 4, and that's why we need to divide by that square root of 4. And that's how we end up with our test statistic of 1.837. So with that, going back to the original question, we see that it actually wants the p-value of this test, and not able to calculate that directly, but we can back into the range that the answers are working with by saying, okay, I'm going to go to my t-table, look at degrees of freedom of 3, because that's sample size of 4 minus 1. And it's even though there are 8 scores calculated, we're only counting the number of observations of differences of scores, and that's why it's 4 and not 8. So 4 minus 1 is 3. And then we want to know what a test statistic of 1.837 is as a p-value, and we see that falls between these two numbers here. And again, this is a two-sided test, so it falls between the 0.2 and the 0.1 shown here in this third row of the table. And so we know that the p-value falls between 0.2 and 0.1. So scrolling up to the options for the answers, we see that the only option is E. So we know it's between 0.1 and 0.2, and E is it's 0.1 or greater, and so E is our final answer. As always, thank you for watching. Please consider subscribing if you find these videos helpful. Thanks.